I'm a program manager for Windows Server. So today I wanted to talk about System Insights, a new predictive analytics feature for Windows Server. But before I do that, I want to pose a question. How would you go about anticipating the resource demands of your server? You could navigate to that server, see what your current usage is. You can see how much storage you're consuming. You can see how much CPU and network utilization is. But really, that doesn't have enough information. There's missing context. There's past patterns and trends within the underlying data that you need to use in order to accurately forecast what that usage is. So really, how do you go about constructing this historical perspective and then forecasting that data? So you could implement some sort of custom script. You could call the right APIs, integrate the right libraries. Then you need to store that data, whether that be in a local text file, an Excel doc, or some database, and then implement the custom visualizations to accompany that data. But you probably don't want to stop there, because this is really hard to scale. You don't want to be checking this graph across all the volumes on your machines, all the servers. And you probably want to implement some sort of forecasting logic. You want to determine what the right algorithm is, have the right machine learning expertise to implement that algorithm, and actually gather the test data to make sure that algorithm is accurate. And really, once you have this pipeline established, you need to do the work to maintain it. Make sure it continues to run across Windows updates, that algorithm continues to be accurate. So hopefully this shows you that just to answer a simple question, there's a lot of hidden cost. You have to do a lot of custom scripts, create your own custom dashboards, and really, there's a lot of operational expense associated with just answering this question. And really, that's what System Insights is designed to address. Hopefully, it'll implement the robust infrastructure to allow you to collect that data, store that data, and will bring the right machine learning expertise to actually forecast that data as well, helping you reduce the operational expenses with monitoring your Windows Server deployments. So System Insights is a new predictive analytics feature natively on Windows Server. All of the predictions analyze system data, so your performance counters, ETW events, or other system properties, with the goal of transforming these burdensome manual tasks into proactive management experiences. So rather than having you write these custom scripts or create these custom dashboards, System Insights abstracts that away or presents you with a simple management interface and allows you to really reduce a lot of those operational expenses that you commonly have when answering these really basic questions. So System Insights is available on all Windows Server 2019 machines, across VMs, across hosts, and it's really agnostic to the hypervisor that it runs on and the cloud that it runs on. Lastly, it runs entirely edge locally, meaning all of your data is collected, persisted, and analyzed directly on your machine. So no data is sent elsewhere, allowing you to save on network costs, but really more importantly, allowing you to abide by any privacy or compliance boundaries of your organization. So that gives a brief overview of System Insights and hopefully helps you understand a little bit of the value that it helps provide you as people who manage Windows Server. So I want to spend the next 40 minutes talking about the following 5 sections. First, giving you an overview of the predictive capabilities in Windows Server 2019, showing you how to use it, showing you how you can create a unified view of the System Insights predictions across a group of machines, how you can implement custom scripts to actually automatically respond to these predictions, and lastly, how you can even extend the infrastructure that we built to add your own capabilities. So first, as you could have guessed, in Windows Server 2019, we're focused on capacity forecasting. Looking at your past historical usage, understanding the past patterns and trends, and forecasting that into the future. We'll do that across 4 resources: volumes, total storage, CPU, and networking. And collectively, these help you plan for future hardware purchases, but also ensures that you have the resources necessary to keep running your critical workloads on your machine. Each of these models forecast using daily data collected for a year. And this is important because it means we're trying to understand long-term trends rather than short-term behavior. We're not collecting this data every minute, trying to understand short-term spikes and valleys. Instead, we're going to understand the long-term trends within that data. Now, a lot of you, when you hear that we collect all this data locally and we're retaining it for a year, are worried about the storage footprint that that might have. But in reality, it's really pretty modest. Across most Windows Server machines, it should be around 5 megabytes. And here's an approximation that you can use. The storage will scale with the number of network adapters, volumes, and disks that you have. But each additional one is just about 250 kilobytes. Lastly, all of these models are trained locally using an autoregressive model. They're trained locally so they can adapt to the specific nuances in your data. But we've also tested this across thousands of machines and telemetry, so we can validate the accuracies and that these predictions continue to be intuitive across really all the telemetry that we have. I'm not going to dive too much into the model. If you want to learn more, you can come up after. I'm happy to dive into the different models that we tried. But this model continued to give us the best accuracies and most intuitive predictions across all of our test data. So in order to make these predictive capabilities happen, we had to purpose-build new architecture in Windows Server. I want to give you a quick technical overview, and then I'll dive into a bunch of hands-on demos in the next section. So first, everything we have really is centered around the data that we collect. We've taken a time series database that was first introduced in Windows 8. So it's a client technology, and it's been there for years, running across hundreds of millions of devices. So we're really confident in the stability and reliability of this database. On top of that, we expose a data management layer. This will actually go throughout your machine, integrate with the right APIs, and collect that data to store it in that database, and it will query from that database as well. On top of that, we have the capability management layer. This is responsible for providing the unified management interface across all of your capabilities. It stores the configuration information, it stores the prediction history and other capability metadata. And each capability itself is its own logical entity. And each one, so the volume capability is separate from the networking capability, and each one of these has to do three things. First, it pre-processes the data, averages it, transforms it, does whatever it needs to do before inputting it to the model. Next, it implements the machine learning or simple statistics logic that go into that predictive model. And lastly, it outputs the results. Lastly, this capability management layer ensures that the right data is collected for each capability. It interacts with that data management layer, and then we'll actually go ahead and collect that data when those capabilities are invoked. Lastly, PowerShell plugs directly into that capability management layer. The important thing here is that all the functionality in System Insights is directly backed by PowerShell. All the commandlets are remotable. Most of the demos I'm going to show are actually in Windows Admin Center, but all the functionality is backed by PowerShell, and Windows Admin Center just uses that PowerShell that we expose for all the functionality that you see. So that covers the Windows Server 2019 capabilities and is a brief technical overview to give you some idea of the components involved. Next, I want to talk about usability, how you can go about using System Insights in most of the common day-to-day management scenarios. So first, how do you go about installing System Insights? Here, within Windows Admin Center, I can navigate to the System Insights extension, and in just one click, I can install. Because we're natively integrated into the operating system, we're able to offer a really simple installation experience without any additional configuration. For those of you who want to use PowerShell, all you have to do is install the System Insights feature and include the management tools as well. So this should just take a couple minutes. I've accelerated it here. And once it's installed, you can see the 4 default capabilities. None of these have predictions yet, but that's expected because we have just installed the feature. Next, once you've installed the feature, it's important to understand the prediction results. What do these predictions actually mean once they're invoked? So here you can see the 4 default capabilities. And each capability reports a status and a status description. The status is the high-level explanation of that prediction, or the high-level gives you the high-level context for that result. And then the status description gives you a capability explanation of that status. So it provides the right contextual info to actually understand what that status means. In this case, it lets you know if you're forecasted or expected to exceed the available capacity. And if you are, it will actually give you a little additional information about the specific volume and the time frame as well. The system insight statuses are okay, warning, or critical, which hopefully is pretty intuitive. And then we've also exposed 2 additional ones. None, and this really indicates we don't have enough data yet to make a prediction, and error, meaning we hit some unexpected error at runtime. Now to map those statuses onto the forecasting capabilities, we'll output okay if you're not expected to exceed the available capacity, warning if you're forecasted to exceed that in 30 days, critical in 7 days. So now that you know how to install and really interpret those results, I'm going to dive into a couple demos that show you how you can use System Insights. So here we have the System Insights dashboard. You can click on any of these capabilities and invoke them anytime. This generates an on-demand prediction, and each one should complete in just a few seconds, and that dashboard should be automatically updated. Each one of these capabilities also has an associated state. When you disable a capability, that means it can no longer be invoked, either on demand or on a periodic schedule. Now for this demo, I'm going to go ahead and re-enable that capability so I can have it continue to run in the background. So you can also, in addition to these on-demand predictions, you can also set a periodic schedule for each of these capabilities. This ensures that System Insights is continually invoking that capability in the background, so it's forecasting using the latest data that you have. So here you can see the default schedule across all the capabilities. They all run every day at 3 a.m., and this is designed so they don't conflict with the normal operations on your machine. But as you've seen, each of these predictions complete in just a few seconds, so really the computational overhead is pretty light. You can adjust the schedule as well. We have a variety of different schedule types. You can enable or disable scheduled predictions, or you can choose between minute, hourly, or daily schedules. Here I'll specify every day of the week, and I'll have this run every 3 hours. Once I've done that, I can click Save, and that saves the schedule for me. And I can go ahead and close this. So in addition to setting schedules and invoking these capabilities, you can also click on each of these capabilities and see both the high-level information presented at the top, the status description, and when it was last run, but you can also see an interactive graph below that has both the historical data and the predicted data. Here, you can also see that the schedule is already reflected. I've just configured this. Previously, it was invoked only every day. And you can also hover over individual data points here to see your specific usage that day. System Insights will also store the last 30 times, or the last 30 prediction results, and you can see those below. Lastly, some of you may have noticed that some of these capabilities forecast on multiple objects. So the networking capability or the volume capability forecasts across multiple volumes or multiple network adapters. Now to show you what that looks like, here are 3 volumes, one of which is forecasted to exceed the available capacity in the next 7 days. The high-level status reflects the most severe status across all volumes or all network adapters. And here's the history for this capability as well, which is a little more interesting because you can see previously I'd been getting a warning status, and now I have a critical status. So that actually covers most of the day-to-day management scenarios of System Insights. Next, I want to show you that even though System Insights runs on a single machine, you can easily have a unified perspective of the predictions across a group of machines. So the first, as I said earlier, all of our PowerShell is remotable. So you can use PowerShell to aggregate the results across a group of machines. Here's a simple script which defines a couple different machines that I want to pull the results from. The script loops through them, determine what capabilities are enabled on that server, and then grabs those results as well. So to show you what that actually looks like, I can open a PowerShell window, And then first, I can define those servers that I want to collect that information from. Here are a couple of VMs that I've had running for about 2 to 3 months, so they have plenty of data. And then I'll go ahead and just copy that exact script that I showed on the previous screen. 2019, yeah. And so once I've done that, I can see what those results actually look like. I can see I've collected them across the first and the second machine, across all 4 capabilities because they are all enabled. And within each capability's result, you can see 5 things. The high-level information like the name, the status description, and when it was last run. And you can also see the location of a JSON file. This file contains all of that historical data and also all of the prediction data as well. And this is actually how Windows Admin Center is able to plot those graphs. So if you have your own custom visualizations, you can actually access the raw data here, or if you just want to go take a closer look. So that covers PowerShell, but I know a lot of you have existing monitoring software that can actually allow you already to have this perspective, this multi-machine perspective. So what we've done in System Insights is that we've structured our events in such a way to easily integrate with those existing services. Each System Insights status maps to its own event ID. So you can easily target these services to look for a specific event, and that indicates a specific status was generated by one of these capabilities. Now, I imagine a lot of you are already familiar with SCOM. So my next demo, I actually want to show how you can set this up with log analytics. So here, again, I have my four default capabilities, one of which is forecasted to exceed the available capacity. We can see here one of my volumes is forecasted to exceed the available capacity in the next couple of weeks. So next, I can actually navigate to the Azure portal, where I've already set up my log analytics account, and I've already downloaded the agent onto that machine. It's actually the same agent that's used for SCOM. Then I can see that I've already set this up with the server that we were just looking at. You can see that on the right here. And within this advanced settings view, I can then tell log analytics to start looking for these System Insights, this System Insights data. I can choose the System Insights admin channel, add that, and then click Save. So this means log analytics is now configured to start looking for all of those System Insights statuses and event IDs that I showed on the previous screen. Now back within log analytics, I can configure my custom log that will actually start looking for these statuses. So here I'll write just a very basic capability. This capability will say, give me all of the events that are essentially mean a warning or critical status. So I think it's 148 or 50. And I'll click Run. I don't get any results back, but this is expected because I've just configured log analytics to start collecting this data. It was more just to determine I have no errors in that script. I'll save this query in case I want to modify it for later. And once I've done that, I can actually go ahead and set an alert based on this custom query. I'll click Set an Alert here. And you can see that query right here. I'll go ahead and click on that. And I can see my query is in this pane to the right. And below that, I can specify my actual alerting logic. Here I'm going to say the number of results returned by this query is greater than 0, meaning one of my capabilities, any of my capabilities really outputted a warning or critical status. And then I'll configure this to run every hour and look at all the data that had been collected in that previous hour. Once I've done that, I'll go ahead and define some additional alert metadata just to identify this alert. Say something generic like alerts when System Insights generates a warning or critical status. I can also define the associated severity of that alert. In this case, I'm choosing warning. Once I've done that, I can actually create the action group that's associated with this alert. This means all of the actions I want to take. In this case, I want to do something really simple, like send an email to an admin. I'll go ahead and choose my resource group, and then I can plug into Log Analytics and Azure Alert's existing infrastructure and use their email functionality. Here I'll specify an email that I've created just for this demo. I'll click OK, and then save this alert. Then, once I've done that, I can come back A few hours later, I'll have re-invoked that capability, and hopefully this alerting logic will have already run. I can navigate to Mail. I can see that I'm not only registered with the Azure Monitoring Services, but now I've received an email indicating one of my capabilities has outputted one of these statuses. This email contains all the information I need to understand what's going on. It shows me what computer generated that status. It shows me which specific capability, and also all the information contained within that event. So really, to summarize what I've done, I've showed you that you can easily use these existing services to pull from the System Insights event log and actually generate a unified perspective across all of your machines, and then also extend that to send me an email whenever one of these critical or warning statuses occurred. So lastly, I want to talk about some new functionality we actually haven't introduced yet. So when we designed System Insights, we wanted it to run across all Windows Server instances. But in talking with you all, we realized how critical it would be to not only look at local volumes and local storage, but actually look at clustered storage as well. So we're really excited to announce that you can actually extend these forecasting models to look at clustered storage as well, so your clustered volumes and clustered disks. Now, the default behavior of System Insights remains unchanged, but I want to show you how you can actually enable that. And all this functionality is already in the latest Windows Admin Center GA release. So first, if you've just installed System Insights and you have failover clustering enabled on your server, you'll be presented with this dialog. You can configure this right now, or you can actually manage these settings anytime using the new clustered storage button located at the top of the screen. This button will only be visible if you have failover clustering enabled on your server. Once I click that, I can manage 3 different settings. The top one enables or disables clustered data collection. So it starts collecting all of that clustered volume and clustered disk data. And below it, I can actually modify the specific behavior of these capabilities. For the total storage capability, I can say, look at the local subsystem or clustered storage subsystem. And for the volume capability, I can say, look at local volumes, clustered volumes, or both. Here, I've already set up the settings I would like. I'll go ahead and click Close. And to show you what that looks like, I'll click on the volume forecasting capability. The overview and forecasting sections look the same, but here I see my 3 local volumes. And then right below that, I can see my 4 cluster volumes as well. Volume 2 was just created, so it doesn't have enough data yet to make a prediction. But really, to concretely show what's going on here, I can navigate to Server Manager, and I see I have 3 local volumes. And then I can navigate to the Hyperconverged Cluster Manager, and I see here are my 4 clustered volumes as well. So hopefully this shows you that within Windows Admin Center or within System Insights, you can easily extend these forecasting models to address clustered volumes and clustered disks. You can really do this at any time, and you can also modify this behavior using any of the clustered storage settings that I showed previously. So that covers how to construct a unified view of the System Insights predictions across a group of machines. I showed you how you can use log analytics to send an email, but System Insights actually allows you to implement your own robust custom scripts to actually respond to the specific statuses of System Insights. So each capability can output 1 of 5 statuses, and each of these statuses can have an associated script. This can be any custom script that you write, and when a capability returns that status, System Insights will go and invoke the associated script if you've configured one. Now, to show you what that looks like, I have a really simple demo. Here I can see my volume capability is forecasted to exceed the available capacity because one of my volumes right here is forecasted to exceed it in the next 6 days. I've written a basic script. This script will determine what volumes have a critical status, and then I'll output those volumes to a local file called criticalvolumes.txt. Now, to create this action, I need to upload it to the server or an accessible UNC path. I'll go ahead and do that right here. And once I've done that, then I can configure this action to be run. Navigate to settings and click on actions. And here I'll specify the path to the script, as well as the credentials that should be used to run this script as well. Once I've done that, I'm going to go ahead and invoke the capability. And that, in turn, will trigger that script that I've just created. I'll navigate to files, and I can see the critical volumes.txt file has already been created. I'm going to open it, open back up System Insights, and I can confirm that the contents of that file matches the volume that's supposed to exceed the available capacity. So I know this is a trivial example, but hopefully it shows and illustrates how you can configure custom actions to be automatically invoked based on the results of the capability. So some possible actions that we think could be interesting in the context of these capabilities: you might want to run disk cleanup, extend volume, or enable deduplication. You could live migrate VMs, or even integrate with new services like Storage Migration Service or Azure File Sync. So for my next demo, I wanted to focus on Azure File Sync. So for those who aren't familiar with Azure File Sync, it allows you to leverage fully managed file shares directly in Azure, but also retain Windows Server as an on-prem cache. So all of your data continues to be accessible locally. You benefit from having that low latency access times, but also you can tier that data to Azure and benefit from having a bottomless storage tier for your cooler data. So here, I have a separate VM where a different volume is actually forecasted to exceed the available capacity. I'm going to click on Files and really confirm that that volume is indeed running low. I can click on Properties for my E drive. I can see that I have about 500 megabytes of free space for a 5 gigabyte volume. And so it's really, yeah, we can confirm that this is running low on storage capacity. Here, I've also already uploaded the script that will be used to invoke Azure File Sync. And then I can go back into System Insights to show you what my current utilization actually looks like for that volume. So this is one of the same volumes I showed earlier. I've just been periodically adding dummy files to this to trigger a critical prediction. I'm going to skip the step where I actually type in the path and the credentials. And instead, I want to talk about what that script actually does. So here, this is a snippet from that script. It's about 150 lines, and I'll upload that later. But I'm going to go ahead and blur that out and only speak about this at just a high level. So before doing that, I had to download the AFS agent, create the sync service, and register my server. This will actually all soon be handled by the Azure File Sync extension within Windows Admin Center. But once I've done that, then I can do the following 5 steps to trigger Azure File Sync. I'll determine which volume reported the critical status, securely authenticate to Azure, define my sync variables, so things like the storage account name, the file share name, the storage sync service name. And then I'll create the cloud endpoint, the sync group, and the server endpoint. Once I've done that, Azure File Sync will immediately start tiering that data up to Azure for me. And I can actually specify how much free space I want to be left on that volume. In this case, I've specified 90% just to be dramatic. But in reality, you might want to do something closer to 50 to 80%. So a day later, once the script has been invoked, I can see that that sync group's been created, that file share has been created as well, and that server endpoint has been registered. Back within Windows Admin Center, this is all the next day, I can see that capability is now reporting an OK status. And again, you can look at the date. This was invoked the next day at 3 a.m. And I can look at the usage itself, and it's dropped dramatically because a lot of that data has been tiered to Azure. Here, whereas previously I had been reporting a critical status, I'm now reporting an OK status, and I didn't have to intervene manually. Once I've configured the script, the rest is really handled for me, and I don't have to go do anything on that server. To again confirm what those volume properties look like, I can navigate to Files, click on Properties. And now, whereas previously I had only 500 megabytes of free space, I have now 5 gigs. And all of those files, all those dummy files that I've created are still accessible, even though a lot of them are tiered up to Azure. So hopefully this demonstrates that these actions are not just designed for these dummy scenarios, but can really be integrated with complex services, and you can really depend on them to automatically address the results of these predictions. I've uploaded a couple scripts here to help you get started, and I'll upload this one shortly, and I encourage you to go take a look. So lastly, System Insights ships with an extensible platform that actually allows you to add new capabilities dynamically without updating the operating system. We announced this a couple months ago, and we have plenty of documentation. But to actually go about creating a new capability, there's really two main steps to do that. First, you specify your data sources. System Insights allows you to start collecting any custom performance counter or any custom event log entry. Once you've done that, then all you need to do is write the prediction logic that analyzes the data that you previously specified. Once you've done this, that capability will start collecting all that data, and it will also be immediately integrated into the System Insights management interfaces, and you can do things like schedule it or create actions. But rather than just talk about it at a high level, I wanted to show you what it actually looks like to write one of these capabilities. So for those of you who aren't familiar with C#, you don't need to worry. You do not need to do this to manage System Insights. But for ISVs and OEMs, this could be an interesting scenario for you to even implement new capabilities to address new scenarios, because you do not need to update the operating system at all to implement these new capabilities. So for this demo capability, I'm going to output an OK status if the average queue length in the last 24 hours has exceeded my historical average. I'll output warning if it's exceeded twice the historical average. And I'll output critical if it's exceeded 3 times the historical average. I'll also use the none and error statuses to indicate I don't have enough data or an error occurred at runtime. So here within Visual Studio, I'm going to walk through a little bit of code, but my intention is not to actually walk through the code itself, but really to show you how a capability is structured at a high level and the workflow you need to follow to create one of these capabilities. So the first thing I'm going to do is add the System Insights NuGet package. This contains all the interfaces and classes and dependencies you need to create one of these capabilities. I'm going to go ahead and install that. And once I have, I can see within my references, I now have 2 new files. And again, these contain all the classes and all the interfaces you need to write one of these capabilities. Once I've done that, I can start writing this capability. I'm going to go ahead and cheat and pull in this capability they've already written. And I wanted to point out 2 things. First, this is all it takes to register a new data source. In about 8 lines, I can say start collecting the average disk queue length, and System Insights will start doing that for me. Next, this is the entirety of the prediction logic. It determines if the average queue length has exceeded the historical average by a specified multiplier. The rest of this is about 150 lines of just parsing that input data and outputting the result correctly. Once I've done this, I can build the solution. I can go find that DLL. And this is what I'll use to actually register that new capability. I can see that it's been successfully created right here. So once I've done that, I can navigate to Windows Admin Center. And I need to upload this DLL to the server. This can't be a UNC path. This actually has to be the server itself. You can see I've already done that right here. And once I've done that, I can navigate to PowerShell. I can use the add insights capability commandlet, specify the name of the capability, and then the location of the capability library. Once I've done that, that means this capability will be immediately created. And as I'll show right here, it's automatically and immediately added to the System Insights overview page. It's never been invoked yet. That's to be expected. But it can actually try invoking it right here. I haven't collected any data yet, so I'll get back a none status. But as you'll see, it's already integrated into System Insights. I can do things like set a schedule, set actions on it. It's really a first-class capability or first-class citizen within System Insights already. So I can even come back a day or two later, or actually probably 3 days later, and I can see that this is now successfully reporting an OK status, and I can even re-invoke that capability just to confirm that it's running properly. So hopefully this shows you how this extensible platform allows Microsoft or third parties to innovate and add new features and new capabilities without having to update the operating system at all. We can move really rapidly and address new scenarios with your feedback. So hopefully this is encouraging for those who want to actually write your own capability, or exciting for those who just want to see us add more. So please provide your feedback. Let us know what scenarios you care about, and we can actually start implementing them and do that all without having to update your operating system. We have plenty of resources online to help you get started writing these. We have our API, we have sample capabilities, we have high-level documentation, so I encourage you to go take a look. So that really covers the 5 sections about System Insights. Hopefully this has showcased some of the functionality that we have, and also giving you the confidence to immediately go and install and start using this. I want to thank you a lot for coming. Please go ahead and install System Insights. We have plenty of documentation. We have videos to help you get started. And please let us know what you think. Your feedback is really critical to helping us improve this and adding more capabilities going further. I'll go ahead and leave this up here, but thanks.